Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Makno. We are from Group 3, together with my other 4 group mates, which is Amin Shafiq, Hazim Mansur, Azim Zulkafli and Haris Johari. We will be presenting for air distribution group assignment. There are 2 teams assigned to our group mate, which is human comfort and air distribution for team 1, and team 2 is air movers and fan technology topic. We will start our presentation with team 1 topic, which is human comfort and air distribution.
Okay, my name Muhammad Hazim bin Mansur and my group member is
Muhammad Amin Syafiq bin Muhammad Ramli.
Today I'm going to present for team 1 about human comfort and air distribution. Okay, I will cover for condition point of typical HVAC. Okay, condition point of typical HVAC are the location of air conditioning state with thermodynamic process. Okay. There are more important location for air conditioning are design condition, return condition, outdoor condition, mixing condition and supply air condition. Okay, there are 3 ways generally conditioned air introduced room, okay, such as outdoor air, 100% fresh air supply, mixing air, combination of return air and outdoor air, and the last one is return air is the air return from space. Okay, there are 2 properties of air, indoor air and outdoor air. Okay, the next subtopic is important factor for air conditioning process. Okay, there are 3 important factor. Okay, the first one is room sensible heat factor. Is the ratio of the room sensible heat to the total heat. Okay, room sensible heat factor can be plotted by using the projector on chart by sensible heat factor scale on the right of the chart and parallel line is drawing from the design state point to saturation line. Okay, the next is grand sensible heat factor. Is the ratio of the total sensible heat to the total heat of room plus outdoor. Okay, grand sensible heat factor can be plotted from the mixing condition to saturation line. Okay, and the last is bypass factor. Is the amount of air past the coil unchanged. Okay, next I will pass to my member.
Okay, thank you Muhammad Azim. Now I'm going to continue with the presentation. For my part, I'm going to present about 3.6, representation of conditioning points and important factors on psychometric chart. Here, I'm going to explain about how you to accomplish in order to complete this type of question. Okay, first one is you must draw schematic diagram of air conditioning plant. The number 2 is you must plot room condition R on psychometric chart. The next step is you must plot O on psychometric chart. O that means stand for outside condition. After you finish plot point R and O on the psychometric chart, you must join the points of O and R. Okay, for the next one is you must find the mix point M by measuring the length of the line OR that you have plot on psychometric chart and multiply this by the mixing ratio. Okay, you must find the room ratio. This is the sensible to total heat gain ratio. For example, total heat 0.8 kilowatt sensible plus 7.2 kilowatt latent is total 18 kilowatt total. For the heat ratio, 0.8 divided by 18.0 equal to 0.6. Okay, after that, plot this ratio on the protector bottom segment on the psychometric chart and transfer this line onto the chart so that it passes through point R. Okay, for the number 7, the step is plot the apparatus dew point, or we call ADP, of the cooling coil. This is on the 100% saturation curve. The ADP is 8% Celsius. 8 degrees Celsius, sorry, I'm mistake. Okay, the last one is the number 8. You must join point M and ADP. After you accomplish all the steps, you will finish this type of question on psychometric chart. Okay, that's all from me. Thank you for lending your ears.
Hello, my name is Muhammad Hazim bin Ahmad Zulkafli. Today I will like to present the team 2 for the assignment, which is air movers and fan technology. For the first subtopic, 6.1, which is fan principle. Fan is the prime mover and air system or ventilation system. Fan is an essential component of all heating and air conditioning system. Thus, it is necessary to distribute air through ductwork to space that is to be air conditioning. Next, for the second subtopic, which is 6.2, fan type. Fan can be classified into 3 main types. The first type is centrifugal fan, axial flow fan, and special design. As can be seen in the poster, the first picture is centrifugal fan. The second picture is axial flow fan, and the third picture is special design fan. For the centrifugal fan, it has 6 types, which is forward curve, backward curve, radial tip, radial blade, airfoil, and backward incline. And for the axial flow fan type, it has three type for the axial flow fan, which is propeller type, tube axial type, and vane axial type. And for the special design, it has 4 type, which is mixed flow type, cross flow type, tubular, centrifugal, and power roof ventilator, which is axial and centrifugal. And for the next subtopic, I will give to my friend Haris. Thank you.
Thank you, Mr. Azim. So, my name is Muhammad Haris bin Johari. We proceed fans performance. Right. For fan performance, it is well known that the airflow in the duct enclosure resistant due to the friction. Next, to overcome heat resistant, energy in the form of pressure must be supplied to the air. Next, rotating fan impeller exert a force on the air, resulting in both flow of the air and increase the pressure. Next, as you can see, the graph for both forward and backward curve blade centrifugal fans, the P developed as a slight peak in the middle range flow. The P drop off as flow increase. The BHP required for the forward curve flat fan increased sharply with flow, but with backward curve flat fan, the BHP increased and the BHP increase only gradually peak at maximum and then fall off. And as you can see here, efficiency is higher in the middle of the range flow. And lastly, a higher maximum efficiency can be achieved with backward curve flat fans. So the other topic is fan selection. How to select a fans? First, static pressure resistance PS is calculated. And next, second, from the manufacturer data, the required CFM against the system static pressure resistance for the right fans is selected. Selection criteria: energy consumption. So that's all for me. I will proceed. I will pass to Mr. Akmal. Thank you.
Okay, thank you, Mr. Haris. So right now I'll be presenting about fan rating, which is in subtopic 6.5. So there are two ways of finding fan rating. First way is to find fan rating is by using performance curve. Based on the performance curve, engineers are able to visualize changes in fan brake horsepower (BHP), static pressure, and efficiency. The performance are available from the manufacturers, or we can predict from the fan law. Fan law is the relationship among fan performance for a given fan operating at changed conditions or for different size fans of similar construction. It is useful to predict performance when conditions are changed. Next way to finding fan rating is by using fan rating table. Fan rating table already replaces large number of curves, and it is used more often because it is easier to read. But mostly operating condition at maximum efficiency is not clearly understood, and some manufacturers resolve by noting the point of maximum efficiency in the table. So here is the example of fan rating table. Okay, that's all from us. Thank you very much.